Okay, welcome friends. We are into 18th module and we are going to see something which is not there at all in C. So, it is very different, very new to the programmers of C++. It is called exception handling, and that is the important thing that we are going to discuss today. Before we talk about exception handling, we must know what an exception is. Exception is an abnormal condition which is being reported, or something which is strange, something which is different than normal is being reported. Normally, something which is abnormal, something which is to be reported are errors, and we know that whenever you write programs, you will have to deal with errors. I am not talking about syntactical or logical errors that you deal with, but the errors that you deal with while executing the program. For example, if somebody provides a value which is to be used in denominator and it is equal to 0. Now, that kind of an operation is not possible to be used, or the user supplies a file name which is not there in the disk, or user tries to add something to the disk where the disk is full. So, there are some issues which very difficult for the program when encountered. It is very difficult for the program to continue. So, those situations are known as exceptions. Exceptions are almost always errors, but then exceptions is a little bigger term, it can include other things. So, we will be talking about those exceptions, how C++ manages them, and what exception handling mechanism is. C does not have any exception handling mechanism. The methods used in C were not very good in terms of standardization. So, we will be looking at that as well. So, and how exception handling improves that situation is also discussed in this particular module. We will have one more module after this, we will throw more light on exception handling. Basically, in these two modules, module 18 and 19 will be talking about exception handling. Okay. C way of handling error is quite untidy. For example, anybody can write any error message and quit. Now, there is no standardization of error messages or error numbers or anything. It is quite untidy. You may do it, you may not do it, and when the errors are just displayed, they are displayed and nobody takes any action on it, it just go without being noticed. There is no mechanism of controlling that if this error occurs, then a program should not continue, program should take an evasive action or something. There is no compulsion on anybody. So, it is quite untidy and obviously non-standard. Anybody can do it in any form that deems fit to him. Okay. Other languages like Java and Python, if you have studied, they have very structured mechanism of exception handling which manages errors. So, I am not going to discuss how those languages do it, but we will be throwing some light on how C++ do it. But then there is an important difference which is a very common difference across multiple attributes in C++, is that even exception handling is not forced on programmers. Unlike Java or other languages, you can use coding like you do in C, you can still use C type the error handling mechanisms is absolutely fine. If you want, C++ exception handling is there for you. If you do not want, there is no need. Okay. And many programmers do not use C++ exception handling for a very different purpose, but that is absolutely fine. Okay. Exception handling process actually allows you to progress or stop based on the requirements in a very standardized way, okay, in a very systematic way. You one programmer report an error to the other programmer is in a systematic standardized format is possible using exception handling mechanism. Error is just one type of exception, but we are going to that is the most important type of exception, that is normally what an exception is understood as, and we will be only talking about that part. So, exception as errors and other things, not at other things. Okay, let us try to look at traditional C ways of finding errors and managing errors, not only finding errors, but managing errors. And there are three basic methods. The first method is called error number. Now, what you do is whenever you are writing a program, normally you write int main and then at the end you probably have written 0 without really knowing what this means. This means when you say return 0, that means your program is successfully ended, and if you do not, the program does not end with successful this thing end, you will have to return some other value, but that value is your own idea. Okay. You may return 1 for disk full, you may return 5 for file not found and so on and so forth, it is your this thing. It is your function, you decide what is the error number that you are returning. And if you yourself are using that function, it is absolutely fine, and this is normally the concept in C, that you define your own functions and you use them. Okay. When you use library functions, they do not use this method, because if they start using that method, the problem is that we will not be in a position to understand what is the error value mean, but somebody else has written it. And that is a very crucial problem with this method, because unless you have a structured way of telling, like error number 1 is always file not found, or 2 is this, 3 is this, 4 is this, then that makes sense, but there is no standardization of any sort. So, it is basically a programmer's choice and nobody else's. And the other method is called global flag. Now, that is normally used by the system programmers, okay, those who have written system program itself. For example, many times when you try opening a file using fopen or something, the standard library function, when they find that file is not there and the user is trying to open, what it does, it sets a global flag value to something. Now, there are many ways of checking that global flag value, but one of the simplest way is to call a function called p error or print error. Okay. So, that p error will not only get you that value, but it will also display message according to that value, and those values are standardized, unlike the case number 1. These values are very standardized, they mean very clear thing even across systems. Okay. So, if you are running a program on Unix or Windows, your p error will almost always return the same error message, okay, or similar error message. But then it is not there for you as a user, you can't use that method. These two things are very different. This is better standardized method, but you can't use those methods. And the other problem is with this method, because this is done by system, it only remembers the error value related to the previous execution. For example, if you say fopen and then try to write something to the file. So, fopen, immediately after writing fopen, if you write p error, you get the error related to fopen. But if you do not write, you write after the reading or writing or some other operation, then p error message is redirected to just previous statement and not that fopen. So, you can, if you want to check the status, you will have to check it immediately, and after which it is not available to us. System global flag continuously changing based on the current operation. Okay. So, that is the other problem with this p error method. One more method which is also quite generally used in C is to just terminate the program. If the user supplies a value which is not possible to be used in the expression next, what you will do? You just terminate. Okay. Or you, good programmers, some better programmers will try going back to the loop, accept one more, give one more chance to the user to enter the value, and so on and so forth. Sometimes this system works, but in many cases this won't work, especially when you are writing a function, where the input is coming from some other place. Now, you do not have that control from where the information is coming. You have received a value which is not acceptable, you can't do anything but to terminate that program, because you can't go back and ask the calling system to change the value. Okay. So, in many cases the only option available to us is to call exit or abort. Okay. But then the problem with this method is that when you exit or abort, you may be in a state which is called inconsistent. You probably have opened some database connections, you have opened some files, and you probably have opened some network connections. You are in the middle of all that, and then exit occurs. So, when exit occurs, everything is in limbo, nothing is saved. So, your program may be in inconsistent, seriously inconsistent state, which result into problems sometimes. So, there is a need for built-in mechanism for salvaging before you quit, at least. Okay. So, and the standardization and all that. So, looking at these three methods that is generally used, there is the option available with C++ is this thing. Okay. So, this is something which I have already talked about, and this is exit and the problem with exit or abort. Now, the problem is there is one more thing which I must talk about before we embark on this exception handling available with C++. There is something called library user and library creator or designer. The library designer is a person who write many functions, they are core programmers, usually they write all functions. For example, there is a graphic library which is being used, which is being created. So, this person will design the code for say drawing an object, for example. You just provide dimension, will draw an object for you at that place on the screen, or the frame, okay, then generally called the frame, and frame is actually mapped to that screen. So, you just say that on 25 I want to draw this particular object and will draw it, and then the user will be able to call assume that functions called draw to draw that object, shrink to a specific size, grow to a specific size, and those functions just assume that you are the designer and you are writing those functions, and whenever user supplies some value, your function will accept those value and act on it. Now, you are not the user, somebody else is going to use this function later when it deems fit to him. Now, you do not have any control over that, you are writing this function and that is only under your control. So, what you are going to do, if the dimensions provided are not appropriate, for example, something which is being shrink, it is too small that the original this thing is lost, what will you do? You will have to report an error. Now, you are not going to act on that error, because you are going to report to the error to the person who is trying to shrink that object, or you try to grow, then it is growing beyond the screen boundary. Now, again you are not going to be the person who is going to take an action, somebody is going to call your function should take an action of. Now, your duty is to report to him, telling him that this is the problem. You cannot just say anything, you just say that the dimensions are beyond the screen, or object is shrink into too small a size, you just say so. Whenever a library user uses it, for example, if I am using it for drawing an engineering object, some object, okay, some tool or table, or just assume that I am drawing an aeroplane, and left wing is going out of the screen, and when I am calling that function enlarge or grow, the left wing is going out. I should send a message that the left wing is going out, but then what I get the message when I call that function is that the part of the object is going out of the screen, and I have to at that time, because I am calling that function, I know that which part is going out, I will have to specifically write that, and if I write so, the person who is running my program will be able to understand what exactly is happening, or maybe I am drawing a football ground on the screen, and because I have provided wrong dimensions, the left post is going out of the screen, it should say that left post is going out. Please understand that the function, the person who has written that grow function or enlarge function will only say that these dimensions, this object is going out of the screen. He does not know what object is. The person who is using that is actually mapping that code for a typical object, and you will have to say that you are talking about that object. Okay. So, this is very important thing. A library designer has to deal with some idea about the object, he has no real idea about the object, some object is being drawn, and this is the problem with it. So, whenever a function is called and there is a problem, that they report error to the designer, to the user, and user will act on that. So, this is a model on which the current industry works, and the conventional error handling mechanisms will not work with this model, the exception handling does. Okay. One needs the control over the exit process, the other problem. For example, you can't just proceed further, you have to terminate the program, but then remember the problem, if you just exit, the problem is that you have done many things, you have opened some files, network connections, you have defined some objects using say new, is dynamically allocated memory, and you just exit without closing those objects, without making sure those objects destructors are called, we have a memory leak. So, that is something which we do not want. So, there has to be a mechanism where this is done automatically. It is normally in conventional C system or even C++ system, whenever you are exiting, you will have to remember the objects that you have defined, and you will have to pick up each object and then call the destructor. You will have to do it yourself. If you forget to do it, it is gone, the memory is, the leak is introduced. So, we want an automated system, actually we do not want to do it ourselves, let the system do it for us. So, there is no error, there is no problem, actually all objects created prior to that exit should be properly destructed. So, we need that kind of a solution. and the exception handling actually provides that this thing. Okay. Please understand, library user decides all cases where the function can throw. They write the function, when they write the function, decide that this is where there is likelihood of an error, and throw that message back to the person who is using that function, that see this is happening, and let him decide what to do. User maps those exceptions and generate actions to be taken. Now, I am the user, I know what I mean by dimensions too big, or this part is going out of screen. So, what exactly is going out of screen, I will have to decide, and I will provide that information, and so on. Programmer decides the flow of action here. That is again very important. Unlike the earlier case where you just call, exit and abort and just throw in the towel, you do not really do that thing here. What you do is, you systematically closes everything that you have done before, and you have that control in your hand. Okay. You do it, you do everything, you just write the code for doing it as and when this is called, it is automatically invoked and the job is done. You do not need to do it yourself. Okay. You will have to just specify what you want to do once, and that will always happen. Okay. He not only can do it when you need to exit, but he can even mitigate the situation by doing some remedial work. Okay. So, that is and we will soon see what that mean is. And I have already talked about this object destroy problem. Whenever you have some objects which are created using dynamic memory allocation, either using new or you may even use malloc, but people do not use. New is a far better system. But you use new or malloc, then there is always a problem. Problem is that when you call new, you allocate memory yourself, and if you do not use delete, the problem is that the memory is not deallocated and the program ends. And currently C++ 11 compilers which are coming into the market provide something called garbage collector. So, they understand this and remove that memory leak. But if you are not running that kind of a compiler, the older compilers will not have that garbage collector built in. So, you do not have that facility. So, what you are supposed to do is to figure out this thing and write delete yourself. If you forget to do it, there is a memory leak. Here the advantage is that you write the destructors which do it, and you make sure that whenever the object goes out of scope or an exception is thrown, the objects which are defined prior to exception being thrown are automatically deleted. That means their destructors are called automatically. So, that is the this object destroy problem can be managed here. In fact, exception handling can also specify what to do, for example, emptying buffers etc., to make sure that there is no inconsistent state. Okay. There are three components in exception handling system, either C++ or any other language. In most languages the structure is the same. You have in fact, there are three things, as I said. Throw or throwing an exception generally happens with the designer. So, designer, whenever the designer is writing a function and whenever he finds something which is inappropriate, he will just say throw and will provide an object with it, and that object is received at the other end. The user receives that object, will look at that object value and decide what to do. So, normally the objects are thrown, and there is some standard objects also available. Okay. So, remember we have seen that there is a method for system in C++, and there is a method for programmers also, and they are not the same. Here the same thing is allowed for us as well. So, we can also throw, we can write a function where we can write throw, and system also, system functions are also designed to throw. For example, conventional new, if you call normal new in C++, and there is it cannot allocate memory. So, it will throw something called bad alloc. So, you can actually do that and actually play around with that. So, both of them are being used. Okay. So, and the designer uses throw, and whenever the user uses a function from that library, what will do it, whenever it suspects that this code contains some function calls is likely to throw an exception and will encompass that thing in something called a try block. So, is say try, and then there is curly braces under which inside which you write this code containing the call to this function. So, whenever there is a function inside which throws an exception, you have a catch statement coming next. just after try will look at that and take an action. Here is an example. Okay, here is the class. We just define this class is our own class for throwing an exception. I just call ex new, exception new. Okay. It is a very simple class containing only two items, exception number and exception message. Okay. I can actually, normally you have a function to write the expression, but I am keeping it very simple right now. Okay. So, what I am doing is, I just say, you can say that I am actually, this is a designer, this is the user code. Okay. I am going to use this thing and I am actually throwing. Okay. Normally this is not the case. Throw only happens through the function, most of the cases is the library function that you are using. But anyway, this is a very simple program which indicates all three components of it. Okay. So, this is the try block, inside that you have throw. It has to be within the try block, okay? Otherwise this catch makes no sense. Catch immediately should follow this. So, you are sending catch error 1, this catch statement actually catches this, okay, and it matches the type. Error 1 is of type ex new, okay, and then will write both values, okay, exception number and exception message. It is a very simple this thing. Okay. So, please understand that is a very simple mechanism. In fact, it can be little complex as well, all three of them. One thing I must tell you, that the catch immediately must follow try, okay. If it is not, is an error. Okay. So, here what if I am throwing something else and a catch contains something else? If it is so, exception handling system run something called terminate, a function called terminate, and that terminate in turn call abort, which aborts the system. Okay. So, is basically terminating the program in an abnormal fashion. Okay. And if you have written anything after the throw, once the exception is thrown, it is thrown permanently, the control is transferred permanently, it will not come back, unlike function calls. Okay. If this is a function call, the function is executed and the next statement will be executed after the function call is over. That is not the case here. This throw transfer the control permanently, even if it is caught properly or not. Okay. So, if you have written something after the throw, it will not be executed. Okay. Okay. There are many challenges in this approach actually. In fact, it took a lot of time for C++ designers to provide this. There are a lot of technical challenges, a lot of other issues. So, here are a very brief idea about what the problem is. Programmers need to know what exactly happens under the hood, what happens when you throw an exception, how it works, how this, there is something called stack unwinding, because when you throw an exception, all everything defined before that exception is to be undone. Okay. So, the objects are to be destroyed and so on and so forth. So, those things, how they are done. So, you must know exactly how this happens, and if you do not really know, you will have a serious consequences. If you just use exception handling in your program without really knowing, you will see strange answers sometimes, and many cases people do not really understand exception handling and refrain from using it. It is not as bad as it is touted, but it is difficult to handle in many cases where you do not know how you have use your exceptions unless you do it in a very smart way. It is a very structured design, it demands very structured design. If you have very structured, well designed system, exception handling can become an excellent support. Okay. A programmer has to also learn about system exceptions. For example, bad luck, if you just use new without try, and if the memory is not allocated, the program is terminated, you do not really know what has happened, and you assume that C++ is doing things behind your back. It is not the case. Okay. You must understand that many system functions now throw exceptions. So, you have to enclose them in try and then use catch to understand what has happened, and you may take evasive action if need be. A bad cast in case of dynamic casting, we will be talking about later. Okay. and when you are calling a third party function, you do not really know what kind of an exceptions are thrown, and if you do not know, that is a problem for you. So, you will have to know what kind of exceptions are thrown when you are using a third party function, and you will have to manage that. That is the other additional requirement or challenges when you use exception handling. I can't just use any function. For example, I can't just use sqrt without managing, without thinking about the exception. If I do not know, my program will get terminated when it square root gets a negative argument or something of that type. I have to manage this. For that, I must know how it works. Okay. And this is one more problem. Polymorphic objects, whenever they are thrown, they have their own complexities, but that we will not be talking about right now. When we talk about polymorphic objects, we will see what is the problem with it. Okay, stack unwinding process, and whenever you call throw, okay, whatever the objects defined before, they are to be undone. Okay, so that is stack unwinding process. Okay, that is very hard actually to implement. C++ designer took a lot of pain in doing it. The other problem here is, now the exception has occurred, and now unless it is caught, it is not considered to be handled, it is still on. So, when you are unwinding those objects destructors are called. Now, the problem is you are already handling one exception, it is possible that a destructor calls an exception, that is the other problem. Now, two exceptions at the same point of time are not possible to be managed. The program will prematurely terminate in that case. So, that also is very critical problem, and C++ designers have provided a solution which we will be talking about in the next module. Okay. There is something called uncaught exception. Okay. Propagation of control in exception handling is like this. Okay. It is quite possible that function A calls function B, which in turn calls function C, and it throws some exception, but then it will, these statements will not be called, because this function has called this, will come here, but even this part is not called because the exception is not handled, will come here. Now, there is a catch, and if it matches this catch, the exception is said to be handled here, and the control will come back, will not go back, these statements will not be executed. Okay. If I have try block here and have catch here, and if this exception is handled here, will return normally. So, these statements will be executed, and there is an example coming up which talks about this propagation of control. Look at this. This is a function, okay. This is a library function which throws some error. Okay. Normally, you check for some condition and then throw. Here we are not going for that complexity, we are just saying that there is a throw which is being called. This xgen calls that function throw ex, okay, which in turn throws exception, which is caught here. Okay. So, function, the first function is calling the second function, and second function is calling throwing something. The first function is managing it right here. Now, this first function is being called by main. So, main calls xgen, xgen calls throw ex. Okay. So, there is the same thing which we talked about. Okay. This is main generate gen x, xgen, and then the trojan. Okay. But we are checking the error here, right here. So, that is okay. This is the last function, this is the second function which is being managed here, and because it is handled here, this statement is executed. So, you can see that is happening here. Okay. Okay, what you can catch actually, the catch statement, suppose if you are throwing an int, will catch unsigned? Suppose if you have defined catch unsigned value, can it catch int? No, it is very restrictive, but then it catches the exact type, and it also catches the exact variable of the very type. It catches both type as well as variable, we will soon see. It also catches a derived type from base class, we will be able to see that thing later. Okay. Will also, an interesting catch is a void pointer, any type is caught by void pointer. Okay. So, here are those things. If there is one try block defined under the other try block, if the inside try block cannot handle it, it passes to the outside try block. If it is not possible to be managed by the outside try block, we will call terminate. Okay. We have already seen. Okay. So, I can actually write multiple catch statements. When I write multiple catch statements, it is called catch block. After the try, assuming just assume that there is a try somewhere here which is throwing some values. So, if int is thrown, write something here. If character is thrown, whatever is written here is executed, and so on and so forth. But then interesting part is this, catch dot dot dot, that means catch all. So, if it is not int char or new x, anything else will be handled here. Is very similar to the default case in case of switch case statement. Okay. With that note, we will conclude this first module on exception handling. What we have seen in this module is how one can, what is the real need. In fact, we began with real need. The C mechanism of handling error has some problems that we have seen, especially a problem which is that it is not standardized, and when you have two different classes of programmers, library designer and user, you have a problem passing this information in a standardized way. Okay. So, whenever somebody is designing a function who has no knowledge about who is going to use it, and the person who is using it has no knowledge who has designed it, and you need a mechanism which passes this message in a standardized unambiguous form, and exception handling provides that. We have seen three components of exception handling system: try, catch and throw. And throw is used by the designer normally, and try and catch is used by the user. And we have seen one or two small examples of how those components are being put to use. We have also seen that it is possible, normally you call library functions within your function, and whenever you do that, you will have to have call them thing inside the try block, which should be immediately followed by a catch block where the matching takes place. With that note, we will conclude this module, folks. Thank you very much for being with us.